Hi everyone! Today we are going to learn the chapter of spectrophotometry. Spectrophotometry is an analytical method based on the selective absorption of light by material molecules. So let's start with the basic principle of spectrophotometry. We have just mentioned that spectrophotometry is based on the selective absorption of light by material molecules. These methods include calorimetry, UV visible absorption spectrometry, and infrared spectroscopy. Here, we mainly discuss the visible absorption spectrometry, also as spectrophotometry, the detection target of which is primarily matter ion. The spectrophotometry measures the absorption degree of molecules to light, belonging to instrumental analysis. Compared with the methods of chemical analysis learned before, spectrophotometry mainly has four features. First, high sensitivity, which enables spectrophotometry to determine few or trace components. Second, simple photometer equipment, easy to be operated and fast to get result. Third, high accuracy. The relative error is 2% to 5%. Which meets the requirement of trace determination. 4. Wide application. Most inorganic ions and organic compounds can be determined. It is not only for quantitative analysis, but also for qualitative analysis of certain organic compounds. In addition to the determination of some physiochemistry constants and a composition of complexes, let's review the basic properties of light. It's well known that light is a kind of electromagnetic wave with wave-particle duality, which can be described by parameters such as the frequency, wavelength, speed, energy, etc. The relationship between the parameters can be given by the Planck equation. The Planck equation reveals the relationship between the wave and particle nature of light. Light with different wavelengths have different energy. The shorter wavelengths, the higher energy, while the longer wavelengths, the lower energy. The electromagnetic spectrum is obtained by arranging light in the order of wavelengths, also known as the spectrum for short. The regions of spectrum can be divided into gamma ray, X-ray, ultraviolet light, visible light, infrared light, microwave, radio wave, and so on. What we call visible light is the electromagnetic radiation with wavelengths ranging from 400 to 750 nanometer that can be sensed by the eyes. When a beam of sunlight or white light passes through a prism, it is dispersed into red, orange, yellow, green, indigo, blue, or violet colors of light, which have different wavelength ranges. In turn, these different colors of light mix at a certain intensity ratio to form white light. The two colors of light that we see opposite at a straight line are complementary colors. White light, such as sunlight and incandescent light, is a mixture of complementary colors. We can see that purple and yellow-green light, blue and yellow light, and blue-green and orange light are all complementary colors. These complementary colors are mixed at a certain intensity ratio to form white light. Just now, it is said that spectrophotometry is based on the selective absorption of light by material molecules. So, how do molecules absorb light selectively? For molecule species, there are a series of discretely energy levels, including electronic, vibration, and rotational energy levels, which are quantized. The electronic energy level can be divided into the ground state and excited state. In general, the molecules of matter are in the lowest and most stable ground state. When irradiating the molecules, if the energy of light equals the difference between energy levels of molecule species, light of these wavelengths can be absorbed by molecules. resulting in an energy level transition and promotion to a higher energy state. Different molecules have different compositions and structures, and they have different characteristic energy levels. So the difference of energy level is different accordingly. Since the molecular species can only absorb electromagnetic radiation with energy equal to certain energy level difference of molecules, different materials have absorption selectivity to light with different wavelengths. The electronic structure of matter is different, and the absorbed wavelength of which is consequently different. This forms the basis for the selective absorption of material, and based on which qualitative analysis can be performed. Under certain experimental conditions, the absorption degree of light is directly proportional to the concentration of the analyte, based on which we can carry out quantitative analysis as well. When a substance absorbs certain electromagnetic wave with energy equivalent to the visible light, it presents the color that human eye can perceive. The reason why substances have different colors is a result of selective absorption of visible light at different wavelengths. When matter irradiated by light, it absorbs light with certain wavelengths and displays the specific color. Therefore, the color that material exhibits and the light color it absorbs are complementary. If the visible light shining on the substance is completely absorbed, the substance emerges as black. If the visible light shining on the substance is not absorbed and penetrates the substance completely, the substance is transparent. When visible light irradiates the material and the yellow light of which is absorbed, the material appears blue. The copper sulfate solution, for example, is blue because it absorbs the yellow light in the white light. We irradiate a certain substance by monochromatic light of different wavelengths and measure the light absorption degree of material at each wavelength, which is so-called absorbance. Taking wavelength as the abscissor and absorbance as the ordinate, we can obtain a curve of absorbance as a function of wavelength, called absorption curve or absorption spectrum, which can accurately describe the absorption of material to variety light of different wavelengths. Let's have a look at the absorption curve of potassium permanganate solution at different concentrations. As shown in the figure, for the same material at different concentrations, the curve shape and the maximum absorption wavelength remain constant, while the absorbance increases as the concentration becomes higher, based on which the quantitative analysis of analyte can be performed. The sensitivity of absorbance measurement reaches climax at the maximum absorption wavelength. So the absorption curve is a selection basis of measuring wavelength for absorbance spectrophotometry. Here are the summaries of the basic principles of spectrophotometry. Spectrophotometry is an analytical method based on the selective absorption of light by material molecules. When light acts on substance and visible light with certain wavelengths is absorbed, the substance exhibits specific color, which is complementary to the color of light absorbed. Different substances absorb different wavelengths of light, based on which we can do qualitative analysis, and the implement of quantitative analysis is based on the fact that absorption degree of light is proportional to the concentration of substance. Finally, here's a question for you. How do the maximum absorption wavelength and absorbance change for a certain substance, complying with Lambert-Beer's law when the concentration of substance increases? For today. Thank you.